Hi guys, in this particular video we're going to look at exponents of or rather integrals of exponential functions, and in this particular case we're going to use two specific rules in trying to of course find the integrals of those exponential functions. So the first one is going to be the simple exponential rule, and for the simple exponential rule we're going to represent it using the integral of ax. Going to assume that we know the value of a. This is a natural log. So a of x dx, which is going to be represented as a of x plus c. So the simple exponential rule, this is the implication of the simple exponential rule being given as such. So we're going also to look at the second part, which is the general exponential rule, just as we had done for the power rule, for the simple and the multiple power rules respectively. So for the general exponential rule, we're going to see that an exponent of eu d u dx can be given as such. So we have introduced the function of u, of course, which is going to have a derivative, which is going to be a factor of that specific function for the power rule. So this is going to be an analogous procedure for the exponential rules, or rather for the exponential function which has been transferred from the power rule, the general power rule, as we had mentioned in our first video. So for this is going to give us the integral of eu du being given as such, and then this is going to give us eu plus c as the final value of that specific exponential function. So these are the two rules that we're going to apply in order to find the integrals of exponential function, and I'm going to use one of the examples so that we can be able to appreciate how that one can be able or can be done insofar as integration is concerned. So I'm going to do away with this and give one of the examples that we can use, of course, to find the integral of a function. Now suppose we have given this specific expression and requested to find, or asked to find, what we refer to as the integral of 2e to power 2x dx, and therefore we're going to identify that part as that has been raised and try to give it as a function of u. And for us, and therefore we're going to say let 2x be u, and therefore the du dx is going to be a value of 2. So in order for us to find the value of a dx, and dx is going to be represented as du over 2 given as such. So in trying to rewrite our integral, which is the integral of 2 e u, and then dx can be represented as du over 2, and therefore these specific values are going to cancel out, and this is going to be given as the integral of eu du. We had looked at the integral of exponential, the integral of what we had referred to as the simple power rule, and for the simple power rule, then therefore it's going to be applicable from this particular point, whereby we see that the power that is a natural log raised to this specific power for its integral value is going to be that specific integral plus a constant, and therefore we're going to have this one represented as eu plus c, and we're going to restore, of course, our value for this specific expression for u that we had given. So therefore the value of u is going to be e2x plus c as the final value of this specific integral. So that's how we can be able to apply the simple power rule, as from this specific point, by trying to infuse this concept of a function of a u, which has got which is going to have a factor or a derivative that is also a factor of that specific function. So if you try to look at perhaps a second example for this, we can be able to use this one perhaps using one of the integrals which consists of a logarithm, or rather a logarithm function, or perhaps a trigonometric function, and try to see how that one is going to work out. So we're going to identify this part of u that we had said. So for our case, then we're going to say this: let the cosine of x be u. Therefore, we're going to write our integral expression, and then that is the sign of x, a, rather, just start from here. So if we have let cosine of x be u, then du over dx is going to be represented as the sine of x, and therefore the dx is going to be given as du over the sine of x. And in our case here, then therefore we can be able to write our expression as the integral of as the sine of x a u. Then for du we are going to have for dx we are going to have du over the sine of x, and this sine of x is going to cancel out and give us the integral of u du, which basically is going to be of course solved using the symbol rule, the simple exponential rule that we had mentioned, and therefore this is going to give us eu plus c. Now, in doing a substitution for this specific value, we had said that u is going to be represented by the cosine of x, and this is going to be the cosine of x plus c as the value of that specific integral. So this is also another way in which we can be able to find the result of the integrals of those specific functions. So in our next discussion, we're going to look at the logarithm rules, perhaps which are going also to assist us find out how we can be able to deal with specific types of integrals, which of course are going to involve logarithmic functions. So that is it for now, guys. Catch us in our next discussion. Bye. God bless.